So we know we've got many, many billions of tons of carbon available, fossil carbon available. We also know that since the Industrial Revolution started in 1750, we've burned about half the carbon we're allowed to before we go above 2 degrees centigrade of warming. So we've got the remainder of our budget, the other 50% of our budget will be burned by 2045. So we've got very little time to start capturing the budget. And what we need to be is in a position where we extract 1 ton of carbon out of the ground and we balance that with 1 ton of carbon injected back into the ground. And that will be a sustainable use of fossil fuel. Why should we do this now? Because we've been producing fossil carbon since 1750 without putting anything back into storage. All of the carbon we've produced as extra fossil carbon is in the atmosphere and it's acidifying the ocean. What we need to do is realize that we have the technology to do this. We've got a huge carbon debt that we've accumulated in the atmosphere and ocean. We need to start repaying that debt back into the carbon store below ground. We can do that now. We know how to do it. We know roughly how much it will cost. But the longer we wait, the worse the problem will get. Geological carbon dioxide storage is actually very simple. It's the reverse of extracting gas from out of the ground. We're catching some gas, liquefying that as liquid carbon dioxide and injecting that through a drill pipe into a porous sandstone reservoir deep below ground, about 1 kilometre or deeper below ground. And we're trying to mimic or reproduce natural carbon dioxide accumulations which exist in Germany or in France or in the North Sea or in the United States, where we know that we have porous rock with carbon dioxide in those tiny pore spaces, and it's got an impermeable lid on the top of a rock which does not let fluid flow through it quickly, so that carbon dioxide stays in the pore space, floats up to the impermeable lid, but stays there for tens of millions of years. We know a lot about the technology to capture, transport and inject carbon dioxide. There are several companies also worldwide who will now supply industrial scale carbon capture equipment to fit onto power stations or even onto some industrial sites. So all this can technologically be done. And there are projects which have been operating in the North Sea, capturing carbon dioxide from oil fields and re-injecting that. There are projects which have been operating in the continental United States, which are catching carbon dioxide, transporting it and storing it. And in 2014, a large power plant in Saskatchewan, Canada, will open up as the first fully commercial power plant with carbon capture and storage. So the problem is not how to do it, but the problem is how to put it together. And so that's really the missing bit now. We know where to put carbon dioxide into storage sites. We know where some storage sites could be, which retain carbon dioxide for many millions of years into the future. But the missing bit is the money, the finance to make that work, and the political will from governments to encourage and maybe even sometimes to make companies do that thing. In spite of all that knowledge, then there's still a large amount of public perception to overcome, because many people think, quite wrongly, that carbon dioxide is a very dangerous item to store below ground. And it's well understood how to store methane below ground, and many places onshore in Europe, in Germany and in France, in the UK, store methane below ground. And carbon dioxide injection below ground is very similar, but less dangerous, because carbon dioxide does not explode and it doesn't burn. So we need to have a program of understanding and education, a two-way conversation between scientists and engineers and the public who live above sites which could be beneficial for everybody to store carbon dioxide into. And that's a process we need to carry on doing, and it'll probably take several years to build that confidence.